and break them down. And there's 7 different things we need to know about rational functions. And then we're going to look at some graphs. Okay? All right. So, first, I like to put the date at the top of mine. Helps me remember where my stuff is. Okay. So, we looked yesterday and we went over the definition of zeros. Zeros is when it crosses the x-axis. All right, vertical asymptotes. I'm just going to call it VA. Okay, that's what I'm going to shorten it as. Okay, it's when the graph can't exist. There is an invisible line that can't be crossed. So the graph can exist on either side of the line, but it can't go through the line. Okay? End behavior. Where the graph is approaching. In either direction, positive infinity or negative. So we've talked about those things. Now we're going to add some more. Okay? We're going to talk about removable discontinuity. And I'm going to shorten that. I'm going to say end behavior is EB. Vertical asymptotes are VA, zeros are Z, and removable discontinuities are D. Okay? This is where we have a hole in the graph. And we can remove it when we have a common factor. And then we've got discontinuity. Or I'll just put D, which is the removable discontinuity plus the vertical asymptote. Okay. Now we've got horizontal asymptotes. Which I'll put as HA. Okay. This is like vertical asymptotes is a line straight up and down vertical that's invisible. Horizontal asymptotes when the graph can exist. But it is an invisible line that's horizontal. There are 3 cases for horizontal asymptotes. So this is something you want to make sure to write down because you're going to have to use it to answer your stuff. Yes? Horizontal asymptotes, HA. When the graph can exist, invisible line that's horizontal. Okay. 3 cases. 1, degree of numerator is greater than degree of denominator. Okay. So I put degree, numerator, greater than degree, denominator. then there is no horizontal asymptote. Okay, remember there's 2 more cases. I'm going to move it up, but I'm not going to get rid of it. Case 2, the degree of the numerator is equal to the degree of the denominator. Then, horizontal asymptote equals the leading coefficient. Okay. Moving it up. 3, the degree of the numerator is smaller than the degree of the denominator, then horizontal asymptote is y equals 0. If the degree of the numerator is smaller than the degree of the denominator, horizontal asymptote is y equals 0. Yes. This? This?
Yeah.
Horizontal asymptote y equals 0. HA y equals 0. Okay. I'm going too fast, huh? Say it again, Tyler. Yes. When the graph can't exist, invisible line is horizontal. And then there are 3 cases. Okay. Now, finally, there's oblique asymptotes. And we sometimes call them slant asymptotes. Okay? This is only when the degree in the numerator is exactly 1 degree more than the numerator, than the denominator, excuse me. And we find it by dividing polynomials. And we are going to learn that on Monday. Oh, I can't spell it all. Okay, so today we're just going to say if the one exists, and I'm going to tell you what it is, but on Monday and Tuesday we're going to actually find it. All right, now we're going to do some examples. So once you have this all done, we're going to go over some examples. Okay, We ready? Here's example 1. So we are going to, with this example, f of x equals x squared plus 4x minus 5 over x squared plus 9x plus 20. And we're going to find the zeros, the vertical asymptote, the horizontal asymptote, the oblique asymptote, end behavior, removable discontinuity, and then we're going to graph it. Okay. So what do I need to do first? I can't find anything until I do what? Got to factor. So this equals what? X plus 5, x minus 1, or vice versa. Either way. And what does the bottom give us? X plus 5 and x plus 4. Now, just like your quiz, which I know some of you struggled with, what could I cancel out here? Okay. All right. So we're going to ignore that except when we get to the removable discontinuity. Okay? So what is the 0 for this? X equals, not -1, but +1. Remember, it's the opposite. What is the VA? What's the vertical asymptote? X equals -4. Okay, now horizontal asymptote, you have to go back and look. How many X's do I have on top? Are they equal? Look at the degrees. See these degrees? Are they equal? Okay, so if it's equal, it's the leading coefficient. And what's the leading coefficient? Is there a number in front? So that number is what? 1. Okay? Yes, I can totally say that. Yes, Ethan.
So for each problem, we need the factored one and the non-factored one.
You don't have to. So if you look at the factored one, if I was just given this part of it, right, and not given the, we can see how many x's are on top. Well, there's 2, so that's x squared. How many x's are on the bottom? Well, there's 2, so that's x squared. So the biggest thing is going to be that. Okay. All right. Oblique asymptote. Is the top exactly 1 degree more than the bottom? So there's none. There's no oblique asymptote.
What would you put if there was one?
You'd put yes, and then we're going to do dividing by polynomials, which I'm going to teach you on Monday and Tuesday. And it'll be in like a y equals mx plus b form. Because it's like a slanted asymptote. Okay? We'll get there. End behavior. As x approaches positive and negative infinity, what is y approaching? Now think about this. I'm going to stick an infinity into the top. So I'm looking at just this. I've gone and seen that it's x squared over x squared, right? Those are the biggest things I'm going to have. So if we have infinity over infinity, what does that give us? 1. So the end behavior is 1. Okay. So if I was going to plug in infinity for x's, right? It's infinity squared over infinity squared or whatever, right? That just, infinity over infinity just gives me 1, right? Just like 5 divided by 5 gives me 1. Just plugging in those infinities.
How come with this graph you do that, but like for other graphs you do y equals 2?
Okay, I'm sorry guys. I'm trying to explain something, so we need to listen. If you have another question, I would love to answer it. Now, if there was a leading coefficient, okay, and the infinities would cancel out, infinity over infinity, and let's say there was like a 2 on the bottom, you would have 1/2, right? Because if there was like a 2 right here, you get 1 over 2. Infinities cancel out, that's just 1/2, so it'd be approaching 1/2. Sometimes it approaches infinity. We'll keep going. The end behavior, I think the only best way to do it is to keep practicing with it and see different ways that it can work. What is the removable discontinuity? What did I cancel out? X plus 5, which is x equals negative 5. It's the factor in common, top and bottom.
If we didn't cancel out any,
Then there would be none. Okay? Now remember, discontinuity is the removable and the vertical asymptote. So what is the bottom? X equals and x equals negative 4. Remember, it is the RD, removable discontinuity, and the vertical angles, or asymptotes. Vertical. Okay, now we're going to pull out our graph paper. Okay. We can label this example 1. Okay, and we are going to graph this. So, I'm going to graph each part of this. You might want to first, before we do anything else, pull out your calculator. I would go to a graph page. I think it helps to start first. Okay, so I'm going to put this in here. I'm going to put x plus 5. You could put the factored version or the non-factored version. It doesn't matter. X minus 1 over x plus 5 times x plus 4. Okay, so you're going to get a crazy graph like this, right? And I'm going to teach you how we're going to graph this. First thing I want to do is I want to put in my asymptotes. I'm going to put those in with a dotted line. They're invisible. So I'm going to start with my vertical one. It's x equals negative 4. So I go over 1, 2, 3, 4. So this dotted line is my first thing I'm putting on it. Is there a horizontal asymptote? Yeah? Y equals 1. So I go to the y and I go to 1. And I'm going to draw a line at y equals 1. What are you asking me? Okay, so I'm graphing this whole thing right here. Okay, so what I'm doing first is putting dotted lines for my vertical and horizontal axis. Okay, now I know my zeros. I am going to cross the x-axis at 1. So I'm going to put a little dot at x equals, at x is 1. Okay? So far, so good? Right? And I've got a removable hole. Do I have to graph the removable hole? Let me see. Yeah, I need to graph the hole. So I'm going to put a dot in my holes. I have a removable hole at negative 5. So at negative, x equals negative 5, I know I'm going to have a hole somewhere on there where it goes. Okay. So now, I know I'm going to take this line. I'm going to go as close as I can because I'm approaching the dotted line. I'm going to not cross it till 1, and I'm going to keep going. Okay?
So you get close but don't touch it.
Mm-hmm. The next one is going to be here. It's going to be coming close to here. And I might even plug in if x was negative 5, what I'm close to here. looking like this. Okay, but I've got a hole at -5. So I'm going to make sure I put that. Okay. Again, comparing your graphs to your graphing calculator might be a first step in order to do this, and as we get more used to it, we'll be able to do it without. Yes?
So for the numerator of this continuity, it's x equals -5 or not.
X. So here's -5, right? 1, 2, 3, 1, 2, 3, 4, 5. And where that x is hitting, there's no y value there. It doesn't exist. So you're like, shh, nothing.
Why does that happen?
Because we can't divide by 0, right? And while we did take this 5 away from the top and the bottom, it can't exist. We can't ever have a possibility where we could have a 0 on the bottom because a y can't exist on it. So it's undefined. All right. Let's go ahead and do another example. And I think the graph part, I don't know, it's the hardest for me. So I'm going to start off with giving you an example, and I want you to try it. Okay? And you'll try the other things, and then we'll graph together. Okay, so here's example 2. We've got f of x equals x plus 1 over x minus 3 squared. And you're going to find the zeros, vertical asymptote, horizontal asymptote, oblique asymptote, end behavior, removable discontinuity, and the discontinuity. What's the first thing I probably want to do? Okay, what is my 0? I was going to have you guys do this on your own, and then I didn't feel very comfortable. I didn't feel like we were ready, right? Okay. So, what is the vertical asymptote? X equals +3, right? So this is x plus 1 over x minus 3, x minus 3. Sometimes it helps to see it written out. Okay. Horizontal asymptote. Remember, we have to go back. Horizontal asymptote says, now in this case, what's bigger, the numerator, the denominator, are they equal? Denominator is bigger than the numerator. So if the denominator is bigger, the horizontal asymptote is, what do you have, guys? Looking at your notes, 0. Okay? Right. The degree, and the degree means like the exponents. How many x's are there? There's 2 here and 1 here, so the denominator's bigger. Okay, oblique says if the numerator is 1 bigger than the denominator, there's an oblique asymptote. Is that true here?
Yes.
No, the numerator is smaller. So none. Okay? End behavior is where we get messed up, right? So, we can think of this as x over x squared, right? If we ignore all the other stuff, that's just what we come down to. Okay. So, that gives me 1 over x, correct? So, if we have 1 over infinity, what is it approaching? 1 over infinity, that's a really tiny, tiny what? Is it a really big number or a really small number?
Small.
And so what is it getting closer to? 0. So as x is approaching positive and negative infinity, y is getting closer to 0. Okay? Is there any removable discontinuity? There's nothing we cancel out the top and bottom, right? So there's none. So what is there for discontinuity? Okay, if we think of continuity as we never stop, discontinuity means we can't go past that point. All right, let's try to graph this. Again, I strongly suggest stick it in your graphing calculator first. Because when you're trying to get an idea of a picture, again, you will not be able to do that in the future, but we got to get used to it first. So I'm putting x plus 1 on top in my calculator over x minus 3 squared at the bottom. Okay. So now this is example 2. What do I do first? Do you guys remember from the first one? We put our vertical and horizontal asymptotes, right? So my vertical asymptote is at 3. So I go 1, 2, 3, and I draw a line. Kind of. These are just telling me where my graph can't cross. Like, I might be approaching this line, but I can't ever cross it. Okay? All right. Do I have a horizontal asymptote? Y equals 0. So, it says I can't cross 0. Which one? The one that's up and down? The vertical one? 0. Right along the x-axis. I don't feel like that's true that I have a horizontal asymptote at y equals 0. I feel like I might have done something wrong there. Because it definitely goes below it. Because it crosses the x-axis at -1. Okay. And it kind of floats like this. Crosses at -1. I might need to check on a horizontal asymptote again. Okay. You ready for an example that you tried most of it on your own? Except the graphing part? Graphing part we'll do together again. Yes. So let's look at my calculator real quick, because this is what I have for my calculator. You guys see that? See right here in the middle? I have to have an asymptote that goes there. If we went to zoom and zoomed out, it's never gonna, those lines are never gonna touch. They're gonna get really close, but they're never gonna touch. But it does not look like there's a horizontal asymptote, which means I did something wrong. No, because they go below 0, so it doesn't make sense. So I don't know yet. We'll come back. Okay. 3. I want you guys to try this example on your own. Ready? Not the graphing part, but everything else. F equals x squared minus 9 over x minus 3. You're going to find zeros, vertical asymptote, horizontal asymptote, oblique asymptote, end behavior, removable discontinuity, discontinuity. Those things. This looks very similar to what your homework will be. You are not correcting your homework today, but you will be correct. Okay. How are we doing, guys? Where would you put that? Something cancels out. Which one would that be? Zeros or asymptote, horizontal, oblique, and behavior vertical. Removable discontinuation. Removable. Remember there's those three cases of horizontal asymptotes. So, let's see. Okay, let's go over the answer real quick. So I want your attention again. Okay. So we know we can go x minus 3, x plus 3. Over x minus 3, we know these cancel. What are my zeros then? X equals negative 3, right? What are my vertical asymptotes? None. Okay. Kevon, what page are you on? 565. So 565, I'm just double checking what I put for horizontal asymptotes so you guys can have it. It has a whole thing. If polynomials with no common factors, the intersection of the graph. Okay. So if the numerator's degrees are smaller than the denominators, then it's y equals 0. If they're equal, it's the leading coefficient. And if the numerator is bigger, then there's none. So there's none. Oh, so that was what was wrong with number 2, right? Because the bottom's bigger. If not, it should be y equals 0. I don't know why. Okay. So are there any oblique asymptotes? Is it one bigger than the top? Yes. So there is one. You'll have to do this by divide, but I'm just going to tell you right now that the answer is y equals x plus 3. And we'll talk about how to do that with division later. What is the end behavior? As x approaches positive and negative infinity, what does y approach? So we're just looking at x plus 3, right? If I stick it in infinity, infinity plus 3 is still going towards what? Infinity. Done. What's the removable discontinuity? X equals 3. Okay, so the discontinuity is only x equals 3. All right, let's try and graph this, baby. All right. You will not have graphing for your homework tonight, but we do need to practice it. It's usually the hardest part. Okay, so we have no vertical asymptotes, no horizontal asymptotes, but we do have an oblique asymptote at x plus 3.
Staff, please pardon this interruption. Students, there will be an organization in the concession stand today during lunches with free prom dresses. So juniors and seniors, please stop by the concession stand. You can take a look at the dresses and make an appointment for free hair and makeup for the day of prom. Also, remember that the applications for senior prom king and queen and also junior prom prince and princess are due today. Thank you.
Okay, quiet please. So, when we graph this, it has a oblique asymptote, which basically means it's going to be this line. And that's it. All right, guys. Please make sure you do your homework.
Vertical.
Yes, I'm aware. It's just a flag.
Glad to have the canned problems.
As soon as Hunter. So, Hunter, I would really love Hunter.
Okay. I just wanted to, like, wait, you're not in this class. What are you here for?